So we have two curves. One is y is equal a function of x, and the other is x equal a function of y. I want to take you back to the end of last class, before the test, to a comment I made at the very end. And if you recall this comment, I said in general, when you are trying to convert to write curves in parametric equation, or take a curve and write it as a parametric curve, and this is as example 5, said in general, if y equal f of x, you want to let x equal t and y equals f of t. And if x equals some function of y, in this case g of y, then in this case we let y equals t and write x as g of t. That's the principle behind it. Okay? And we're going to take this comment, we're going to apply it right here. So, for part A, where we need to write these two curves in as parametric equations or parametric curves, the first curve is y equals, so let's call it curve number 1. Okay? Curve number 1, we have y equals x to the 5th power. So y equals x, a function of x. We're going to let x equals t, and therefore y will be simply t to the 5th power. Okay? So we're going to have something like this. Because we have 2, then every point on this curve will be x1, y1, right? And so x1 equals t, and y1 equals t to the 5th power. That will be one set of parametric equation. Curve 2 is different. Curve 2 is x equals a function of y. So in this case, if you recall the guideline, we let y equals t, and we let x equals t times t minus 1 squared. Okay, so in this case, we'll have x2 equals t times t minus 1 squared, and y2 equals t. So, and this is the answer. We were supposed to write two sets of parametric equations, and there they are. Now, what about part B? Well, part B is intersections. In other words, we want to have x1 equals x2 and y1 equals y2. But in reality, the intent of this exercise was to for you to do it graphically. I think even the language of the assignment directing you to use calculators. I want to do two things. I want to show you with the graph program, and I want to show you with the calculator. Okay, so I'll start with the calculator. All right, so with the calculator, okay, it's already done it, so this is the end result. So let me take you through the steps, okay? I'm going to clear, I'm going to quit actually, and let's start from the beginning. And first of all, you want to make sure that your mode is in parametric. Normally, this will be the mode, will be in function mode, so you want to change it to parametric mode. Okay, and now you need to enter the two sets. So you go to y equals, and I've already done that. So x1 is t and y1 is t to the 5th. That will produce the first curve. The second curve, remember, y was equal to t, and x is t times t minus 1 squared. So you set it up like so. And then we need to look at the graph. So you can graph it, but let me lead you through normal step. If you want to start, if you don't know anything better, you start with the standard window. So you go to Zoom 6, start with the standard window, and this is what you see. The problem is you see only a result in the first quadrant. Why is that? Because if you go to the window, you can see that t starts at 0. And by default, notice that t starts at 0, and t max, if you recognize this number, is 6.28. This is 2 pi. But, we are not on a circle here. T can represent the time or whatnot. So I'm going to start with t equals negative 10, and I'll go to t equals positive 10. Okay? And look at the graph again this time, and I see that, yeah, indeed, there is a positive and there is a negative deal here. So I want to see the intersection. I'm going to zoom right here, and I see that if I go if I let x go from negative 2 to positive 2, and y go from, let's say, negative 2 to positive 3. So I'll go negative 3 to positive 3 all around. Okay, so let's go from negative, actually, we are not going to change t. Okay, remember, with parametric equation, you control 3 things. You control t, you control x, and you control y. So we let t goes from negative 10 to 10, assuming that negative values of t are permissible. I'll talk about the t steps later on, but let's start with t steps. I want to make a point, so I'll start with step of 1. I'll adjust later on. Here, we talked about x and y. We let x and y go from negative 3 to positive 3, like so. Okay? So now let's look at the graph at this point, and you can see that it's kind of, it's not smooth at all. It has almost line segment. Can you guess why is this? Why we are looking at the graph looks so distorted? Because of the t step, right? We need to get the t. We need to draw the graph with a greater resolution. So I'll change it to 0.1 instead of a step of 1. I'll draw it every 0.1, and you can see that it takes a little bit longer, but the graph is smoother. If I want even smoother than that, because if you look at it carefully, you can see that it's still not smooth, not too smooth. So I'll change that to 0.01, but the trade-off is the graphing process will take longer. How longer it will take? Well, it will take 10 times longer, because we increase roughly, we really don't know the algorithm. It may take even longer than that, but at least 10 times longer. And you can see that here's the first curve. This is y equal to x to the fifth. And you recognize this as an odd power of x, right? You have the serpentine look. It almost looks like y equal to x cubed, except x to the fifth is a little bit steeper. And here's the next one right there. All right? Go ahead.
Why can't you go below 10 to the negative second? It's just the graph.
We can. We can.
Well, no, on the calculator.
We can go below if you need to. I just didn't see a point to go below.
Yeah, because if I go to like 10 to negative 30, it says error window. It's just the calculator.
Because you're exceeding the window. You whatever you do, you need to stay with this on this one, okay? But really, if you do to answer your question, why we can go beyond negative 10 and positive 10 on t, we can. But we need to adjust the physical window, the window of x and y accordingly. Now, the task in part B is to find the intersection. It's clearly that we have an intersection at the origin. To check the intersection, we don't have a good calculating, like in a function mode, we can go second trace into the calculate menu that for some reason is not working for me right now. Then why it's frozen. Man, you see what you did? I don't want to change the color scheme. I don't want to do anything. I just want it to work for me. Yeah. Let me try again. Okay, we need to start from the beginning, which sucks, but that's what it is. So again, changed from function to parametric, and enter the function. So the first function was t, and then t to the fifth. The second function was t times t minus 1 squared. And t. The window, we concluded that we want to go negative 10 to positive 10. Okay. And we go with 0.01. Hopefully it won't freeze on us. Negative 3 to positive 3 all around. We need to... Okay, now here's what we want. Normally when we go to the calculate menu, second trace, okay, we have different options, but here we have dy dx, dy dt, dx dt. We'll talk about it later today. But we need, if we go to value, we need to enter value of t. For instance, if I enter 0, when t equals 0, we are at the origin, if you can see the cursor. Let's see what happens if we let t equal 1. Well, we are right there. And we can actually trace. If I hit the trace button and I can go up, actually I can go right or left, I can pick up an intersection. Right there, I'm close to intersection, and I see that x equals 1.15, but I'm a little bit to the right. If I go a little bit to the left, I'll surpass that. Okay? And if I go to the next intersection, score like this, again, you really cannot hit on it. It's negative 0.784, and I'm a little bit to the right, so it's probably going to be negative 0.8. So obviously that's not an efficient way to find the intersection. I can increase the resolution, in other words, the steps. This is 0.1. With 0.01, I can get a better result. But we do have a better tool, and the better tool is the graph program. And I believe I have it already on my jump drive, so let me see if I can retrieve it from the jump drive rather than recreate the wheel. And let's see. Let's see if it's here. It'll be under right here. Okay, so here's the function in red, and one curve is in red and the other curve in blue. And if you want to see the legend, I can increase the legend. You can see the two curves. So this is y equal x to the fifth, the green, and in the red you see x equals y times y minus 1 squared. We are looking for the intersection. I'll go ahead and select any function, and I'll go and evaluate. Go to calculate and evaluate. I have the icon here. And now here's the thing that you can do with the graph program. I can let it snap into intersection right there. So if I'm in this vicinity, okay, let me actually change the curve right there. Okay, so I snap into the intersection. You see it's negative 0.835. I go right here. It will snap into this intersection, which is 1.12, and the third intersection will be the origin, 0, 0. Now, some of you should ask, can we do it analytically? Can we do it not with this technology? The answer is yes, but you need to solve for t. We need to find the t value for which the function intersects. And this goes back to what I said earlier. If I change now. Okay, in order to solve it analytically, you need to equate x1 to x2 and simultaneously y1 to y2, and you can get values for t that correspond to the three intersections. Okay. One value we know right off the bat is t equals 0. T equals 0 corresponds to 0, 0.